Alrighty, friends, I'm coming to you live to go through this group worksheet. There are several integral problems on the final, and I just wanted to make sure that you had an opportunity to be shown how to do these if this wasn't a comfortable worksheet for you. Okay, so let G be the function graphed below, estimate the value, and one of the things you look for is from where to where. So from -5 to +5, doing left, right, midpoint with 5 subintervals, and then draw the sketches. Clearly you won't be drawing the sketches since it's multiple choice, but you will be doing, have to know how to do the Riemann sums. So don't overthink it. You are doing rectangles and you are doing base times height, where the base is going to be the span of the x's and the height is going to be your y values for each of the x values. So here, if they are going from -5 to +5, that's actually 10 spaces. And if you're using 5 subintervals, they're each going to be 2 wide. So every other line, I have a new interval. So there's my 1, 2, 3, 4, 5 spaces between -5 and 5. But what that means is the base for each of these is going to be 2 wide. So when I go to do my area, I'm going to do base times height, but the base is 2 for all of them. So instead of going 2 times this height, 2 times that height, I'm just going to write the 2 once and then find each height. But this says using the left sum. So that's left endpoint, left sum, however you want to think about it. So just go literally to the left end of each line that I've drawn for the intervals. So for example, in this first one, the very far left at -5, my y value is right here at -2, and it's below the x-axis, so that's going to actually contribute negative area. Anything below the x-axis is negative. Anything above is positive. Okay, then my next one is right here, and I can see that the left end would be right there at +2. Then my next interval on the left end of this next interval, I'm up here and I go over and then I create a rectangle that is 2 across the bottom and 3 high. Now the next interval is going to be this one from here to here, and if you go to the left side, you actually are at 0, so you don't really get any area from that one. And then in the last interval, which is from here to here, from 3 to 5, my left end point is here, which is at -1, and then that would be my area. So I'm not sure if you'll be able to see this. Let's try. This is a rectangle here that has -2 times 2, so an overall area of -4. And then this one's 2 by 2 but above, so +4. So in essence, those two will cancel each other out. This one's 2 by 3, so that's 6. This one doesn't have any area because it's just a line. And then this one is 2 by -1, so -2. So you're multiplying this base by each of these, but you're doing it just by saying, you know what, instead of multiplying 2 by each of them, I'm just going to do this whole thing. So I end up with that 2 out front multiplying by a 2 in here. Because these cancel one another, just like up here, I said the area of those 2 rectangles cancel one another out, and then 3 plus -1. So the area according to that is 4. Then I go through the same process. I go over here and I think, okay, I'm going from here to here. That's my first interval. And in that interval, if I go to the right side, I'm at a y value of this. All of these are going to be 2's again, but now this first one is 2 units, sorry, that one line down here is going to be 2 units above the x-axis. So that's my first height. Then when I go to my next my next interval, I go to the right end of it and I see how high that is. And that is 3 high. Then I go over 2 units to my next interval, and on the right end of it, I'm at 0. So I have a y of 0. So not contributing. Then I go to my next space of 2, and the right end is at -1. So that's contributing area right here, but it's below the axis, so it'll actually take away from what's above. And then on my last one, the right end is at 0 again, so it doesn't contribute. So I have my 2 out in front, and then these all become a 4 inside. So that estimate is 8 using those different rectangles. And if you think about it, this rectangle has a 2 by 2, so that's 4. This is 2 by 3, so that's 6. This one's a line, so that's 0. This one is 2 by -1, and this one is 0. So 4 plus 6 plus -2 is where that 8 came from. Then the one on the far right, I'm using the midpoint. And so I still am using these same intervals, but instead of going by the point on the left end of the interval or the right end of the interval, I'm going to the one right in the middle, smack dab in the middle. And so for my first rectangle, they're still 2 wide, but my first one has a height of 0. Then if I go to my next interval, I get in the middle and I find the y value of the midpoint, and that is up 1, 2, 3, creating a rectangle that's 2 by 3. Then I go to my next interval, and the middle of it would be right here. So I'm going up this high, which is 2 units up. So that's a 2 by 2 square rectangle. Then I go to my next interval, but I go into the middle, which is down here at -1. So 2 by -1. And then the last one's a little bit weird, but that's okay. Sometimes math is weird. So in the middle, I'm right here, but you guys are big brain, so you can figure out that that's about -1/2. So this last rectangle is 2 wide and -1/2 tall. So when I multiply that all out, I end up with 2 times 3.5. So my guesstimate, estimate, midpoint, Riemann sum total is 7. So if I don't have the visual and I just have a table, that probably is one of the options on the test. You have to read what it's asking for. This one is asking for the estimate from 2 to 5, so that's only this much. And then it says using 3 subintervals, and a lot of people came up and were like, that's not 3, but you're talking about intervals. From 2 to 3 is one interval, from 3 to 4 is one interval or space, and from 4 to 5 is another. So those are my 3 intervals, is the space between the 2, 3, 4, and 5. So this says to use the left. Well, if I'm starting on the left, I'm going to start at the 2. Each of these is going up by 1. So in this case, when I go to do area equals base times height, the base, which is really the width of the interval, is a 1. And then I'm using the left. When you are doing left, you never get to the far right value. So my left height is 0.21 because that's my y value. Then the next one would be 0.28, and the next would be 0.36. And I never use this one at 5 because that's on the right end and I'm doing left end. So when I do this math on my calculator, I get 0.85. Now, trapezoid. The trapezoid is where we still use the interval at the bottom, but then we have but now that's called the height of it because we're thinking of it as a kind of a sideways trapezoid. And so this is going to be base 1 and base 2 because in a trapezoid, they have to be parallel. But ironically, those are really heights or y values. And the area for the trapezoid is 1/2 times the height, base 1 plus base 2. But since our trapezoids are turned on edge, this is going to be our interval width, which in this case is a 1 because these spaces are each 1 unit wide. So we'll have our area will be 1/2 times our interval width of 1. And then B1 plus B2, that's the left and right y values, basically, if you look over here. So if I'm going from the left, I'm going to have these two as the first 2 heights of my trapezoid. So I have 0.21 plus 0.28. Then keep in mind that 0.28 is going to be shared with the next one. So then 0.28 gets added to 0.36, but then 0.36 is the shared height, and that gets added to the 0.44. And then those in a trapezoid always repeat except for the first and the last, because those aren't shared. They're the ends. They're the left end and the right end. So when I do that all out on my calculator, I get my answer of 0.965. So the Riemann sum, like I always say, it's kind of clunky. And that one is definitely, like, the concept is easy. Like, you're just finding base times height. But you really have to noodle your way through where those numbers are coming from. So will you need to know that? Yes. Will there be 100 of them? No. So just get yourself confident enough to, muscle your way through a couple. All right. This is actually a tricky part. Indefinite integral, remember you need to end with plus c because you don't know if there was a constant, because it would have disappeared when you did the derivative. So this is where we have to think backwards about our derivatives. Some of these are easy, some of them are not. In the first one, I have power rule. So I always just write what I have for the bottom part. But now the power would have had to be 1 higher than that. And then you divide by that same number, the power that's 1 bigger than what you see here. And so then I'd have a negative 4x. Now this is to the first power, so it would have been to the second power, and then the 2 is on the bottom. Because in the process of doing the derivative, you multiply by the power, so to undo it, you divide by the power. And then the 3 doesn't have an x, so it would have had an x. And then it's just a matter of reducing. So the first one becomes 3x cubed minus 2x squared plus 3x plus c. Because there might have been a constant, we just didn't know it. This one you had to kind of think. And up here, I kept emphasizing that rewriting. And that does potentially happen to you on the test too for derivatives and integrals. You can't do this power outside of a thing that's differentiable. That would be a chain rule. So we don't know how to undo the chain rule yet. So what I'm going to do instead is use my algebra skills. That is the core of calculus. The stronger your algebra skills, the easier calculus is. Because I can FOIL this out. I'll get 9x squared minus 6x plus 1. And now I can do my integral of that using the power rule, just like up above. So I would have my 9x, it would have been to the third, divide by that power. 6x is currently to the first, so it would have been to the second, divide by that power. 1 is hanging out alone, so it would have had an x. And then I'd have a c. But I do need to simplify my answer, and so certainly I would write it as 3x cubed minus 3x squared, because just by simplifying the numbers, and then plus x plus c. Okay, so now it gets kind of tricky. I can't use square roots, so I have to think of this as 3x to the 1/2. And I can't do this next part as an ln. Really know that, because I can only use ln if it's 1 over plane x, and it's not. It's 1 over x squared. So then I have to think of that as x to the negative 2. I am not doing the integral yet. I'm just doing the rewriting. Now they're both powers, and I can do the power rule. So I have to think 3x to the 1/2, but it would have been bigger by 1. Okay, well, that would have been to the 3/2. And so then I have to divide by the 3/2. We'll worry about simplifying that later. And then the second part, x to the negative 2, I would add 1 to that power, which would put me at x to the negative 1, and I divide by that same power. Okay, so let's simplify. Here I'm going to have 3x to the 3/2 power, because 1/2 plus 1. Dividing by a fraction is the same as multiplying by the reciprocal. So I would be multiplying this by 2 over 3. 3's cancel. And then here, I would just, because of the negative on the bottom, I would turn this into subtraction. And then because I have a -1 power, that x would move into the denominator. So what gets tricky about this 3/2 thing, and there's nothing this tricky on the test, is that you would have a third power but a square root. So that's like a little math prison where if you have 2 of something, you can get out. So how many groups of 2 can come out of there? 1 group of 2, leaving 1x inside. So ultimately, I've got this 2, I've got this simplified version of x to the 3/2, and I've got this. So my final answer looks like 2x root x minus 1 over x plus c. Again, the concept on the test. That difficult? Probably not. But you definitely want to know how to go to fraction powers and negative powers. Now, that being said, in number 6, 2 is over a plane x, and 1 over x is ln x. So 2 over x is going to come out as a 2 ln x, because that x on the bottom is plane. And then to get a positive sign, I would have had to have a negative cosine, because the derivative of cosine is negative sine. So if I need it to be positive, I'd have to have started with a negative cosine, and then plus c. We never talked about secant or tangent or any of that. We only talked about sine and cosine. So you have to use your big brain and say, oh, that's the same as 1 over cosine. And again, a stacked fraction, if you're dividing by a fraction, it's the same as multiplying by the reciprocal. So instead of having a 1 over cosine, I'd have 7 times cosine. And now if I integrate that, I would say, okay, well, the integral of cosine would have been sine, and the 7 just stays out front as a coefficient, and then plus c. So the key to success on that is rewriting. And that is something, oopsies, dropped my Apple Pen. Be right back. That rewriting is a powerful tool. When you feel super stuck and you're like, we never learned how to do these, that's what you got to do. Okay, the irony is this last part's probably the easier part. Exact answers simply means no decimals. It means you might have pi. It means you might have e. It means you might have a square root. And that's just something that at this point in our math life, we have to be pretty comfortable with. Because a decimal isn't accurate. It goes on forever, or we round it off, or we cut it off. And so we're losing part of the value. So what we do here is we find the antiderivative, and then we do that antiderivative's value at this top upper limit minus the derivative or the antiderivative's value at the lower limit. So let's just use the power rule. That would bring us to x has to go to 1 higher power than it was and be divided by that same power. And this 2 would have had an x, and then we go from 1 to -1. So then we're just going to plug in the 1. So 1 cubed over 3 minus 2 times 1, and then subtract what happens if you plug in the -1, the lower limit, into that function. You do have to be careful. All the things that are messy throughout Algebra 1 and 2, like cubing a negative, you do not want that to be the thing that gets you when you are in calc. So you have to be really good at, kind of watching and understanding what you should be getting. This comes out to be -10/3. Okay, so here, the antiderivative of 1 would have been x. The antiderivative of a positive sign would have been a negative cosine. We have an upper limit of pi and a lower limit of 0. And some of these we really start to need to know on the unit circle. Pi is over here, the coordinates are this. 0 is over here, and the coordinates are that. Okay, so we need to plug in the upper limit. So that would give us pi minus the cosine of pi. And then we subtract whatever we get when we plug in the lower limit, which is 0. So 0 minus the cosine of 0. Alrighty, well, pi is pi. And then if it says minus the cosine at pi, I look over here, the cosine at pi is going to be a -1. So I have minus -1. And then here I have 0 minus the cosine at 0, but the cosine at 0 is a positive 1. So again, the negatives are a complete nightmare. So this turns into pi plus 1 because these cancel. And then here, minus 0 is obviously nothing, and minus the negative is going to be another 1 when that distributes. So I end up with pi plus 2. And the reason I'm not doing plus c is this is not indefinite. I know the limits, and I can plug in the numbers and get actual values. All right. So let's do the antiderivative. For 2x to be our answer, we would have had to have a power of 2, and we would be dividing by that to work backwards, so that actually cancels. And if you don't believe yourself, check it. Is the derivative of x squared going to give you 2x? Yeah. And then it's 1 over x plain, so that's ln, from a lower limit of 1 to an upper limit of e. So we plug in e squared plus ln e. And then we're going to take that minus, now we're plugging in the lower limit of 1 squared plus ln 1. So use your big brain. E squared is e squared, but ln e is asking you e to what power is e, so ln e has a value of 1. Get comfortable with that because next year that's going to come up repeatedly. 1 squared is obviously 1. And then this, if you think about it, ln 1 is saying e to what power is 1, and so e to the 0 power is 1. So what ultimately happens is the plus 1 and the minus 1 cancel, and your final exact answer is straight up e squared. Last one, find the antiderivative. Well, the antiderivative of e to the x is e to the x. And the antiderivative of 6 is 6x, from a lower limit of 0 to an upper limit of 2. So plug in 2. E to the second plus 6 times 2. Subtract what you get when you plug in 0. E to the 0 plus 6 times 0. So e squared is e squared. 6 times 2 is 12. This is going to be minus, and then this e to the 0 will turn into 1, and 6 to the 6 to the 0 will actually turn into 0. So I end up with e squared plus, and then 12 minus 1 is going to be 11. So those are my exact values. So if that's a concept that you need to practice a little bit, maybe, work your way through that practice sheet again. These are probably at a higher level. I think these are reasonable. Even the square root and the powers, you need to know that for sure. Sine, cosine, that kind of thing. But give yourself a little chance to practice that if you're not feeling confident. Thanks, guys. Bye.